Hello students, welcome to chemistry class. So in the last class we have learnt about some chemical reactions of the amines, that is acylation reaction of amine and carbalamine reaction of amines, or it is also to be called as isocyanate test, and reaction with the nitrous acid, and also we have discussed about the reaction with the Hinsberg reagent. Let us see the few more information about the reaction with the Hinsberg reagent. So what is this Hinsberg reagent? So Hinsberg reagent is nothing but that is C6H5 and it is S double bond O Cl is to be called as Hinsberg reagent, right? So let us see how this Hinsberg reagent reacts with the primary amines as well as with the secondary amines. So when it reacts with the primary amines, that is benzene sulfonyl chloride, yes, double bond O Cl. So it is to be called as benzene sulfonyl chloride. So this benzene sulfonyl chloride reacts with the primary amines. So primary amines means only one hydrogen atom in the ammonia replaced by one alkyl group. Such compounds are generally to be called as primary amines. So when it reacts with the Hinsberg reagent, there is an elimination of one hydrochloric acid molecule. So it gives C6H5 and it is S double bond O and it is double bond O, and the sulfur attached to the nitrogen, right? NC2H5, and this nitrogen contains one more hydrogen. So the molecule, that is the obtained product, is to be called as N-ethyl, that is ethyl group attached to the nitrogen. So it is N-ethyl, and there is one more substituent group, that is benzene, and this S double bond O and NH is to be written as sulfonamide. When Hinsberg reagent, that is aryl sulfonyl chloride or benzene sulfonyl chloride, reacts with the primary amines, it gives the N-alkyl benzene sulfonamide. And let us see the reaction with the secondary amines, that is benzene sulfonyl chloride reacts with the secondary amines. So secondary amines means two alkyl or aryl groups attached to the nitrogen. So this nitrogen contains only one hydrogen. Such compounds are generally to be called as secondary amines. And the reaction between the Hinsberg reagent with the secondary amines, so it gives the product, that is hydrogen and Cl is to be eliminated as HCl. So plus HCl, and it is N, so it is C2H5 and it is C2H5. So there is one lone pair of electrons plus hydrochloric acid. The name of the product is C2H5, two ethyl groups attached to the nitrogen. So it is N, diethyl, benzene, and S double bond O N is to be written as sulfonamide. So that is when it reacts with the primary amines, it gives N-alkyl benzene sulfonamide. When it reacts with the secondary amines, so it gives N, dialkyl benzene sulfonamide. So let us see the difference between N-ethyl benzene sulfonamide and N, diethyl benzene sulfonamide. So when it reacts with the, that is benzene sulfonyl chloride reacts with the primary amines, the obtained compound has hydrogens attached to the nitrogen. But when it reacts with the secondary amines, there is no hydrogen atoms attached to the nitrogen in the product, right? So there is one hydrogen here, but here there is no hydrogens. So what it indicates? So due to the presence of hydrogen atom in the first product, so it is generally soluble in alkali, that is it is readily soluble in bases, and it has acidic in nature, but when the benzene sulfonyl chloride reacts with the secondary amines, the obtained product is generally not in acidic nature. It is not an acidic. Why it is not an acidic compound? Because there is no hydrogen atoms attached to the nitrogen, and this compound generally insoluble in alkali. So very important point for the competitive as well as for the 1 mark question. That is, when the benzene sulfonyl chloride or Hinsberg reagent reacts with the primary amines, the obtained product is generally soluble in alkali and it has acidic in nature, because there is one hydrogen atom attached to the nitrogen in the product. But when the benzene sulfonyl chloride reacts with the secondary amines, the obtained product generally insoluble in alkali and it is not in acidic in nature. Why it is not in acidic in nature and why it is insoluble in alkali? Because there is no hydrogen atoms attached to the nitrogen. So here there is no hydrogen atoms attached to the nitrogen. Hence the obtained compound generally insoluble in alkali. And this Hinsberg reagent does not react with the tertiary amines. Why it does not react with the tertiary amines? Because in the tertiary amines there is no hydrogen atoms attached to the nitrogen. For example, let us take C2H5 and N. So it is C2H5 and 1 C2H5, that is all 3 hydrogen atoms are replaced by the alkyl groups. So Hinsberg reagent does not react with the tertiary amines because there is no reaction between the benzene sulfonyl chloride and with the triethyl amine because of the absence of hydrogens. That is, there is no hydrogens in the tertiary amines. Hence it does not react with the Hinsberg reagent. And next let us see the electrophilic substitution reaction. So the electrophilic substitution reaction of aniline. In the aniline, that is aniline is nothing but C6H5 and there is an 1 NH2 group. That is hydrogen atom replaced by the aryl group. So this compound generally to be called as aniline. So this aniline has more electron density at ortho and at para position. So it is ortho position and it is para position. So during the resonance structures, that is in the resonance structures of aniline, there is a negative charge or electron density more at ortho and at the para positions. Hence the incoming group, that is electrophile, attached only at the ortho and para positions. Let us see how this aniline undergoes electrophilic substitution reaction. So in that first one, bromination reaction, there is 2 chemical reactions. One is in the absence of catalyst and the controlled bromination of aniline. Let us see how to write the chemical reaction. That is first one, in the absence of catalyst. So in the absence of catalyst, that is, so aniline reacts with the, that is NH2. So this aniline reacts with the bromine, generally it is bromine water, that is to be written as Br2 bar H2O. Generally reaction takes place at room temperature and it gives a white precipitate of 2, 4, 6 tribromoaniline. That is, the electrophile is Br. So this Br to be attached at ortho as well as at the para positions. So this compound is to be called as, that is 1, 2, 3, 4, 5, 6. So at second position, fourth position and sixth position there is an bromine, right? So it is to be called as 2, 4, 6 tribromo and aniline. So tribromoaniline. So 2, 4, 6 tribromo and C6 and this NH2 is to be written as aniline. So 2, 4, 6 tribromoaniline. That is, the reaction is reaction with bromine water. Next, let us see the controlled bromination of aniline. Controlled bromination of aniline. So in order to get the monohalogenated derivatives, monohalogenated means only one electrophile is to be attached to the aromatic ring. Such compounds are generally to be called as monohalogenated derivative. So aniline undergoes acetylation. So aniline, that is NH2. So this NH2, that is C6H5NH2, undergoes acetylation. That is, it is to be treated with the acetic anhydride, CH3, CO, and it is twice oxygen. So it is to be called as acetic anhydride, and the reaction takes place in the presence of stronger base than aniline. So it is pyridine. So it gives the product, that is C6H5 and N. So one hydrogen atom, and the next hydrogen atom is to be eliminated along with the acetate ion. So the product is C double bond O and it is CH3. So the eliminated product is CH3COOH. Acetic acid is to be eliminated, right? So this obtained product is to be treated with the bromine, Br2, in the presence of this acetic acid, that is CH3COOH. So that acetic acid is to be generated in the chemical reaction only. So it is not necessary to add extra acetic acid. So there is an electrophilic substitution reaction takes place, that is, the electrophile attached at the para position, that is Br. So it is a major product. So due to the presence of steric hindrance between the bulky groups, so the ortho products are not stable. Hence, The para products are more stable because there is an very less steric hindrance between the CH3CONH group and the electrophile. And next, there is an elimination of the CH3CO in the presence of acid or base. So it gives the product, that is CH3CO group is to be eliminated and the hydrogens are attached to the nitrogen. So it is NH2 and it is Br. So the obtained compound is to be called as 4-bromo, and this C6H4 and NH2 is to be written as aniline. So it is 4-bromo aniline. So when aniline reacts with the bromine in the presence of catalyst, here the catalyst is acetic anhydride and pyridine. So it gives only mono-substituted product. But in the absence of catalyst, it gives the tri-substituted product. That is halogens attached ortho as well as at the para positions. And next reaction, that is nitration reaction of aniline. Let us see how this aniline undergoes nitration reaction. So this aniline, that is NH2, reacts with the nitrating mixture. So the nitrating mixture is concentrated HNO3 and concentrated H2SO4. So it is to be called as nitrating mixture. And the reaction takes place above room temperature, that is 288 Kelvin. So it gives the products, that is the mixture of ortho, para and meta products also to be obtained. That is NH2 and nitro group attached at the para position plus nitro group attached at the meta position and N nitro group attached at the ortho position. So it is NH2 and it is NO2. However, the percentage of the para product is 51% and the percentage of meta product is 47% and the percentage of ortho product is just 2% because of the repulsion between the NH2 and NO2. So here there is one product, that is NO2 group is to be attached at the meta position, right? So it is to be occurred due to the strongly acidic conditions. That is only nitro group, that is NO2, to be attached at the meta position takes place only because of the presence of high acidic conditions. That is aniline is protonated to form anilinium ion, which is a meta directing group. Aniline, that is aniline, undergoes protonation. Protonation means it attracts one proton from the acids, that is nitrating mixture. So it gives anilinium ion, that is NH3 plus. So this anilinium ion, that is the formation of anilinium ion, is the reason for the attack of the nitro group at the meta position. So in the examination they may ask when the aniline reacts with the nitrating mixture, it gives the meta products also. Give reason. So the meta products are obtained under stronger acidic conditions and this aniline is protonated to form anilinium ion, which is a meta directing group. And next, let's see the controlled nitration of aniline. Controlled nitration of aniline. So when aniline reacts with the acetic anhydride CH3 CO twice oxygen. So it is CH3 C double bond O and C double bond O, it is CH3, and the reaction takes place in the presence of pyridine. So there is an cleavage of bond between the CO and oxygen. So this CO CH3 to be attached to the nitrogen by replacing a nitrogen. So hydrogen attached to this group, and the remaining part is to be attached to the carbonyl group. So it is NH and it is C double bond O and it is CH3. Next, so the reaction takes place in the presence of nitrating mixture, that is HNO3 plus H2SO4 at temperature 288 Kelvin, same temperature. So it gives the product, that is nitro group, to be attached at ortho and para position, in which the major product is para substituted product. So we have to eliminate this COCH3 by treating it with the acid or base. So it gives the product, that is NH2 and it is NO2. So during the controlled nitration, only one nitro group to be attached at the para position. So it is to be called as 4-nitro aniline. So during the reaction, that is nitration, in the presence of a catalyst, it gives the mixture of ortho, para and meta products. Here the major product is para product, and the meta product, that is meta nitroaniline, is also to be obtained because of the protonation of aniline. During the controlled nitration of aniline, that is nitration takes place in the presence of catalyst, it gives only mono substituted product. So these are the nitration reactions of aniline. And next chemical reaction, that is sulfonation of aniline. Sulfonation means aniline is to be treated with the sulfuric acid. That is aniline is treated with the sulfuric acid H2SO4. So the sulfuric acid undergoes ionization, so it gives H plus HSO4 minus. So because of the presence of one lone pair of electrons on the nitrogen, so it readily attracts proton and it is to be converted into NH3 plus. And there is one negatively charged particle, that is HSO4 minus. So there is an affinity between the NH3 plus and HSO4 minus. That is opposite charges or gets attract with each other. And the reaction takes place at 453 Kelvin to the 473 Kelvin. So there is an attack of SO3H group at para position. SO3H is to be attached at the para position, right? So during the sulfonation reaction, so the electrophile released is SO3 and SO3H group is to be attached at the ortho or at the para positions. But the major product is para substituted product. And there is an shifting of proton from SO3H to NH2, that is to be written as, so the proton from the SO3H is shifted to the NH2 group, that is because of the presence of lone pair of electrons, so it is NH3 and it is plus, and this SO3 that is proton is to be eliminated, that electron is to be present on the SO3 group, that is SO3 minus, right? So this molecule is generally to be called as Zwitter ion. Zwitter ion, that is, in the Zwitter ion it has both the positive charge as well as negative charge, and there is a shifting of proton from SO3H to NH2 group. So only one reaction for the sulfonation. And next there is one question, that is, aniline does not undergo Friedel-Crafts reaction, that is alkylation or acylation. Why?